Welcome back to Triptych Algebra. Today we're talking about polynomials. Polynomials are some of the most important structures in mathematics. In front of us here, we have three different polynomials being multiplied together. Here we have a monomial. This is a polynomial that only has one term. These other polynomials are binomials. They're two-term polynomials. Terms are what are separated by addition or subtraction. A term is something made up of numbers and variables being multiplied together. The version that we're looking at now, if we think of this as one complete polynomial, is called the factored form of a polynomial. It's called the factored form because it's the multiplication of multiple polynomials. One of the first things we're going to have to do is to be able to multiply two or more polynomials together. In this case, as with multiplying any mathematical structures, we can only multiply two things at a time. In this case, I'm going to multiply these binomials together. It's important to note that when you multiply any two polynomials, every term of the first polynomial must be multiplied by every term of the second polynomial. When I multiply two polynomials together, the way that I keep track of it is what I call with the double rainbow move. What I'm going to do is multiply x by every term in the second polynomial. When I multiply x by the 3x, I get 3x squared. When I multiply the x by the negative 4, I get negative 4x. Now I need to multiply the 5 by the 3x and the negative 4. I get 5 times the 3x is a plus 15x. And the 5 times the negative 4 is a negative 20. I kind of glossed over it, but it's a really important trick when multiplying polynomials together. This plus 5, I think of a positive 5. When I see a minus 4, I think of that as a negative 4. So this would be a positive 5 times a negative 4 gives me a negative 20. The next step would be to combine these like terms of a negative 4x and a positive 15x, give me 3x squared plus 11x minus 20. A really important thing to note is that I still have this 2x squared out front, and so I will carry that down. Again, it's important to note that I couldn't multiply all three of these polynomials together at once. I can only do two at a time. Now what I'm going to do is multiply this trinomial here. A trinomial is a fancy name for a three-term polynomial. I'm going to multiply 2x squared by each of these. Remember, when you're multiplying with variables, I'm going to multiply these coefficients. So this first is going to give me a 6, and then I add the exponents for the variable. So distributing the 2x squared to every term of this polynomial will give me a 6x to the fourth plus a 22 x cubed. Again, to note, that's an x to the 1 power right there. This cubed comes from the 1 plus the 2. Then the 2x squared times the negative 20 will give me a negative 40x squared. This form of a polynomial is also really important. I'll make some points about this, point out some terminology, vocabulary about polynomials, and then talk about the relationship between all of these versions of the polynomial. First to note is that this polynomial, we'd say, is a trinomial because it has three terms. Again, terms are the objects that are being separated by additions and subtractions. By definition, again, a term is an object that has numbers and variables being multiplied together. This polynomial not only has three terms, but another way of talking about this polynomial is that it has a degree of 4. The degree of a polynomial is the largest exponent when dealing with a one-variable polynomial. The last thing that I will point out about this polynomial are the coefficients. The coefficients are the numerical parts, the constant parts of these terms. In this case, this is a 6, 22, and a negative 40. Importantly, as said earlier, the coefficients take the sign of the addition or subtraction in front of them. We would say that 6 is the lead coefficient because it's the coefficient for the term that has the highest degree. When first dealing with polynomials, it's really important to understand how to multiply and simplify everything together, but it's also really important to be able to go back through this process. Just to describe to you the processes we're going to learn to do this, first we're going to learn to factor out the greatest common factor. That is this move from here to here. Factoring the GCF, or the greatest common factor, is the opposite of this distribution right here. It's very closely related to division of polynomials. After understanding how to factor out a greatest common factor, we will then learn how to factor quadratics of this type and factor them into the original factored form. Again, just to make it very clear, what it means to factor is to write something as multiplication. So when you factor the greatest common factor, it means to take this and write it in a form like this, where you've essentially divided out as much from each term that you could, or undistributed. It's very closely related to division. After factoring the greatest common factor, we will then factor quadratics using either the AC method or guess and check.